Welcome to our final video, week 7 video. It's been fun. Let's close out this video with some expectations. We're basically looking at in this final week cloud-based software engineering and how platforms are transforming development and deployment. We're going to talk about secure software development practices. We're going to touch on AI and what AI brings to software engineering, and then also professional ethics. What are some of the what is the role of ethics in software engineering today? Okay, so cloud-based software engineering overview. Okay, cloud-based software engineering uses cloud infrastructure and services for development and deployment and maintenance, leverages remote servers, scalable, all the benefits that were talked about as far as code be used and the use of the cloud to reduce the amount of infrastructure we're going to need. All that still applies, but now we're talking about applying that web-based software to software engineering. It enables global collaboration, fast development cycles, popular platforms, AWS, Azure, Google Cloud, GitHub Actions. And there's three basic services, okay, that I wanted to kind of highlight for everyone. First one is IaaS, Infrastructure as a Service. Provides virtual machines, storage, and network. PaaS, Platform as a Service. This offers runtime environments, databases, and frameworks. And then SaaS, Software as a Service, delivers complete software solutions over the internet. This shows the flexibility that's basically out there in the cloud. That you're not only talking about a software as a service, but you can put entire infrastructures and leverage that on the cloud. It basically says you have the possibility that you don't have to have anything in house. Just use the cloud for it. Benefits and challenges of cloud-based. Benefits, scalability. That's the biggest one as far as if you need to scale up, you just get more cloud resources. Challenges, security risk, compliance. You really have no control over whether something is really truly secure. You have to basically count on the cloud provider that they have the securities in practice that are necessary to protect your particular application. Best practices designed with portability and security in mind. Let's make that one of your priorities. Secure software development, why it matters. Why do we want secure software? Security must be integrated throughout the software cycle. It's not something that you say, oh, let's put this security module in at the very end of the project before we deploy. You have to have that security in mind from the time you generate the requirements to the time you deploy the application itself, where security is fundamentally part of every discussion that you have. Core secure coding practices, input validation, always validate user inputs, authentication and authorization, use strong authentication, and least privilege access, which basically says only allow access for what is needed. Don't be giving access for something that someone really has no need to have. Encryption protects sensitive data in transit and at rest. Error handling, avoid exposing internal details in error messages. And logging and monitoring, track anomalies and security events. Security development lifecycle, SDLC. Normally we associate that with software development lifecycle, but it's appropriate to say security development lifecycle. Requirements, require security goals early. Design, use threat modeling to anticipate risk. Implementation, follow secure coding standards. Testing, conduct static and dynamic analysis on penetration testing. How far can someone get into your application? Deployment and maintenance, continuous patch and monitor. Okay, AI is changing the world. Okay. Some people like it, some people don't, but it's here. AI in software has its advantages. So AI reshaping software, engineering life cycles, it automates repetitive tasks, it enhances developer productivity, it improves software. Uh, Equality through predictive insights and automation enables continuous learning and drives innovation in design. Checks to make sure that you're meeting standards. Okay? Goes in, analyzes code, generates boilerplate and even complex code from natural language, which means that if I have to generate something over and over again, I can apply the AI and AI can give me the boilerplate code that I need. Suggests improvements, detect bugs, enforces coding standards, automates, pulls requests from analysis and review processes, speeds up development. Generates test cases. We talked about that in as far as automation a while back when we talked about testing. So it generates test cases based on requirements, code, user behavior, predicts defect prone modules, and prioritizes testing resources. Using ML models to detect patterns and uncover hidden bugs, continuously learn from previous test results to improve the new tests and to improve the new results. Optimizes CI and CD pipelines for predicting failures and bottlenecks, for running performance and security, automates root cause analysis, analyzes technical debt. So the AI can help you there in that if you don't do something, you don't do something according to standard, it can analyze systems and for you pick out places in the system that you might have a technical debt problem based on what you did previously or what you didn't do previously. It can basically track what the ramifications of that is. Future trends and ethical considerations, explainable AI, ensuring transparency, trust in AI-driven decisions, AI peer programming, human AI collaboration in developing, enhanced creativity, ethical and security challenges towards autonomous software. That's the thing everybody is afraid of. Autonomous software, AI agents managing full development cycles. The fear is that's going to take someone's job. Okay, but AI is moving toward that particular model. Professional ethics in software engineering. Ethics guides how software engineers act in professional settings. Ensures trust, safety, and fairness in technology. Addresses privacy, intellectual property, and social impact. Rooted in ACM and IEEE code ethics. Okay, that is a standards. Both of those are standards organizations. Does your application adhere to the standards of IEEE? They should. Key ethical principles, public interest. You don't want anything that will damage the public interest. You want to be and have your application be application of integrity, be honest, transparent in all work, confidentiality, okay? Protect private and sensitive information, professional responsibility, maintain competence, be a competent user, a competent deliverer of systems, and uphold standards. Respect, knowledge, intellectual property, and diversity. Don't clone, don't take, as far as copyrights, don't ignore copyrights, do all the things that you should do as far as ethical principles. Handling data responsibly, balancing business goals with user safety, preventing algorithmic bias. That is a potential problem, especially with AI giving information. Is the information I give you biased towards one leaning toward one way versus another way? Okay. You always have to kind of look at that to see if is there a algorithmic bias in what the information is getting to me and how am I using it. Okay, well, that's it, folks. Our face-to-face, we're going to be talking about when the projects are going to, presentation is going to be. It might be, we're still going to work out the logistics, whether it's going to be the last day of class, or sometime different. It might be that we have a forum in order to have you present basically on a forum, but we haven't worked out those details. I'm actually recording this before we have made those decisions. So by the time you get to and read this particular or listen and look at this particular video, I would have laid out to you what the plans are for specifically how you're going to present your project to the class and how you're taking the principles that we've learned so far and taken that and produced it on an actual application that's been assigned to you. Well, again, thank you for the time, and I'm sure I will see you on the next meeting or forum, and of course on the final exam. Everybody have a good one. Hope to see you soon. Bye.